Okay, so now we're going to go over the squeeze theorem. If you see it on the internet written in some other ways, some people call it the sandwich theorem. In France, I believe the basic translation is two cops and a drunk guy theorem. And in Russia, I believe it's something similar, like two militiamen and a drunk guy theorem. Okay, so why would this theorem be called two cops and a drunk guy theorem? Okay, so if g of x is less than or equal to f of x, which is less than or equal to h of x. Okay, now my g of x is one of the cops. Okay, h of x is also one of the cops. Okay, f of x is the drunk guy stuck in between them. Okay, now if this cop and this cop are both going to that jail cell, that drunk guy in between them is going to that jail cell. Okay, so that's what's meant by squeeze theorem, or two cops and a drunk guy theorem, is that if these bounding functions, this g of x and this h of x, if they're both approaching this exact same spot, well, then the guy in the middle is going to be squeezed down and he's going to have to go to that exact same spot. Okay? So let's see what we mean by something that behaves very badly, like a drunk guy. So if I looked at the limit as, let's say, x tends towards 0 from the right of sine of 1 divided by x. Okay. Now, as I'm approaching 0 for this guy, what are some of the numbers that I can start putting in? Okay. So I'm approaching 0. So I could put in 1 over pi, 1 over 2 pi, 1 over 3 pi, 1 over 4 pi, 1 over 1,000 pi. Those are numbers that are getting closer to 0. But what happens when we plug these numbers into this? If I plug 1 over pi into this, it becomes pi. If I plug 1 over 2 pi into this, it becomes 2 pi. If I plug 1 divided by 1,000 pi into this thing, it becomes 1,000 pi. Okay? So what happens with this guy as we're approaching 0? Well, it's always going to be bounded between -1 and 1. That's not an issue. That's actually a good thing. Okay? Spot 1, left spot -1. Okay, so my guy's bouncing up and down. Okay, oh no, the oscillations are getting worse. The oscillations are getting worse. They're getting worse. They're just bouncing back and forth radically. Okay? Because you're saying, well, remember, we were talking before that don't divide by 0. Because if you divide by 0, you're going to tend towards infinity. So this ends up with infinite oscillations as you end up approaching 0. Okay? So the limit of this guy, he does not exist. For a limit to exist, it has to approach a single point. This is never going to approach a single point. It's just going to keep oscillating, bouncing up and down, faster and faster and faster, and it's never going to converge to anything. It's just going to be infinite oscillations. Okay? Well, let's look at a slightly different problem. Okay? What if we said, okay, so instead of just this, let's say I wanted to examine the limit as x tends towards 0 from the right. Now x sine of 1 divided by x. Okay. Well, whenever you start, right, squeeze theorem has a tendency to lean itself towards trigonometric functions. Okay? Now, why would it have a tendency to lean towards trigonometric functions? Because there's a natural inequality that comes from our trig functions, mainly that sine and cosine are both bounded between -1 and 1. So I could start off this problem like this. I can say, I know sine is always bounded. That gives me a natural inequality to begin with when it comes to the squeeze theorem. So, say negative 1 is always less than or equal to sine of 1 divided by x, which is always going to be less than or equal to 1. Okay? But I don't want to investigate just sine of 1 divided by x. Okay, I'm looking at x times sine of 1 divided by x, but this is just a natural inequality to begin your problem with. Okay? Now what we're going to do is we're going to multiply this entire problem by x. Okay? So, negative x is going to be less than or equal to x now sine of 1 divided by x, which is going to be less than or equal to x. Okay? Now, this guy in the middle is really who I'm trying to investigate. Okay? But I'm going to examine the behavior of the left and the right function. Okay? Okay. So, the limit as x tends towards 0 from the right of negative x will equal the limit as x tends towards 0 from the right of x. Both of those guys are going to 0. Okay? Okay. So at that point I can say, therefore, by squeeze theorem, okay, the limit as x tends towards 0 from the right of x, now sine of 1 divided by x will also equal 0. Okay? So we created an inequality, and then we said, we started with a natural inequality. The natural inequality becomes by the behavior of the sine wave. Okay? Beginning with that natural inequality, we said, okay, well, why don't I just multiply everybody by x? Great, why not? And then you can say, well, if x is tending towards 0 from the right of this thing, I'm just going to plug 0 into it. Same thing for this one right here. X is tending towards 0. I'm just going to plug 0 into it. Therefore, by squeezing them, since down the left and down the right both go to 0, and the middle has to go to 0. And so let's look at what I mean by 2 cops and a drum cut. So, the boundary of this thing, if I was going to draw the graphical interpretation of this, okay, that's my x right there. That's my negative x right there. Now my x sine of 1 divided by x is going to be trapped inside of this thing. This is not my best artwork, but bear with me. Okay. So, the positive x is one of the cops. The negative x is the other cop. Now this x sine of 1 divided by x, yeah, he's wobbling around like crazy. But he's bounded by these two guys who are going to the exact same place. So it has to go to the exact same place as well. Okay? Okay. Let's examine an infinite one. Okay? Now let's consider, once again, like I was saying a minute ago, this always has a tendency to lean itself towards trig functions because you have a natural inequality that arises from it. Now, if I was going to look at, let's say, the limit as x tends towards infinity of cosine. Okay. So what is cosine? Well, cosine of 0 is 1. Up, down, up, down. And that's just going to go on forever. Okay? towards infinity of cosine of x, it's an oscillating wave. It's just going to go up and down forever. It's never going to converge to something. So for what I mean by converges is it actually goes to one number. It actually converges to a number. This one will never converge to a number. It is a wave. It's going to stay a wave. That's it. End of story. Okay? Huh. What if we looked at a slightly different one? What if I considered this one? Now, some people will throw out the hand-waving argument that cosine's always going to be bounded, and if you divide by infinity, it's going to go to 0. Okay? Remember, but you can say that a constant divided by infinity goes to 0, but we don't have a constant in this case. You can't just kind of throw out that hand-waving argument. You need to actually justify this through a theorem. Okay? So what we're going to do is we're going to start out with the natural inequality that cosine is a wave, always bounded between -1 and a 1. Okay? So, -1 is going to be less than or equal to cosine of x, which is going to be less than or equal to 1. Okay? We know that's true. That's just an inherent property of that trig function. That's not true of all trig functions. Tangent has all kinds of weird asymptotes. So, but I want to look at this guy right here. And this guy just has an x on the bottom. Okay, so what am I going to do? I'm going to take this entire problem and I'm going to divide by x. So, -1 divided by x is going to be less than or equal to cosine of x divided by x, which is going to be less than or equal to 1 divided by x. Okay? Cool. That's where we're at so far. Now I can say the limit as x tends towards infinity of -1 divided by x equals the limit as x tends towards infinity of 1 divided by x. Okay? And both of those guys are going to 0. We have a constant divided by infinity. Right? Then I can say, therefore, by squeeze theorem, the limit as x tends towards infinity of cosine of x divided by x equals 0. Okay? So what are my boundaries really on this one? If you want to think about it this way, there's 1 over x right there that's approaching 0. There's -1 over x right there. Both of those guys are approaching 0. And now cosine is stuck in between them. And so what they're going to do is they're going to squeeze him down and make him, and make him go to 0. Okay? So this is one of the cops, this is one of the cops, and this is the drunk guy in the middle who's being forced to go to 0 by the squeeze theorem.